Hello friends, in this video I am going to teach you about comparison between the frequency modulation and amplitude modulation. In our previous lectures I already told you about amplitude modulation and frequency modulation. In this video I would like to tell you what are the comparisons and what are the differences and what are the similarities between the frequency and amplitude modulation. First let's see the first point, that is the equation for the frequency modulated wave. It is the mathematical equation for the frequency modulation wave, that is AC into sine 2 pi fct plus beta cos 2 pi fmt. Here AC is nothing but amplitude of the carrier signal, Fc is the frequency of the carrier signal, and beta, it's a very important factor, that is modulation index of the frequency modulation, and Fm is the message signal frequency. Now coming to the mathematical representation of amplitude modulation, that is the equation for AM wave, or mathematical equation for AM wave is S of t is equal to AC into 1 plus MA cos omega mt into cos omega ct. Here omega m is the frequency of the message signal in terms of radians, and omega c is also frequency of the carrier signal in terms of radians. Ma is the modulation index of the amplitude modulation. It can also write as a mu. Okay, now coming to the next point, that is the modulation index can have any value, that is beta is less than 1 or greater than 1. Here in frequency modulation the modulation index is beta. It can have any value is less than 1, it can be less than 1 or greater than 1, which means if our frequency modulation signal is narrow band, that is we have two types of frequency modulation. First one is narrow band FM, second one is wide band FM. If our signal is narrow band FM, then our beta value must be less than 1. If the signal is greater than FM, if the signal is wideband FM, then the beta value must be greater than 1. Okay. Now coming to the modulation index of the amplitude modulation wave is always in between the 0 and 1. Okay. Here MA is nothing but modulation index is always in between the 0 and 1. Now coming to the power of the frequency modulated signal. Here it is A. Okay. AC square. Here the power of the frequency modulated signal, that is Pt is equal to AC square by 2R, where AC is the amplitude of the carrier signal by 2R. R is the resistance value. Now coming to the amplitude modulated wave power, that is the power of the AM wave is Pt is equal to Pc of 1 plus Ma square by 2, where Pc is the power of the carrier signal, Ma square is the square of the modulation index, and it is the power of the amplitude modulated wave. Now coming to some more differences, that is the bandwidth. The bandwidth of the AM wave is, we know the AM waves are four types. One is standard amplitude modulation, second one is DSBSC, third one is SSBSC, and the fourth one is vestigial sideband. Now we are consider here standard amplitude modulation. In standard amplitude modulation the bandwidth is equal to 2 into frequency of the message signal. Okay. Now coming to the phase modulation, we know in phase modulation the bandwidth can be calculated by using Carson's rule. Okay, the bandwidth of the FM wave is BW, that is bandwidth is equal to 2 FM of 1 plus beta. It is derived from the Carson's rule. I already told you in Carson's rule how it can be obtained. Okay, this is how to find the bandwidth of the frequency modulated wave. Now coming to the next point, that is it is more affected by noise compared to FM. Here AM is more affected by noise compared to FM. That means here noise is very more compared to the frequency modulated signal, as usually here frequency modulation also less noise affected by the FM. I mean here the noise is more in AM and noise is less in FM modulated wave. Okay, now coming to the one more point, that is the construction is complex. It is exchanged. Here in AM wave the construction is very easy, construction is simple. Okay, in amplitude modulated wave the construction is simple, whereas in the frequency modulated wave the construction is complex. Okay, construction is complex, and here also it is less expensive. Here some of the points are interchanged. In the amplitude modulation the circuit is less expensive, whereas in the frequency modulation the circuit is more expensive. Now coming to the last comparison, that is it is used for short distance communication. Here also some of the point is exchanged, that is it is used for long distance communication. Okay, it is used for long distance communication, and in FM used for very short distance communication. Okay, FM used for short distance communication and AM used for long distance communication. Just to interchange these two. Okay, that's fine. This is about the comparison between the amplitude modulation and frequency modulation. I hope you understand this topic. Thank you for watching this video.